Hello everyone, uh, welcome to our YouTube channel Learning Circle. On this channel, we were doing class 10th series. Okay, so let's resume our previous topic, which is real number. Okay, we were studying real number. So the topic for today is Euclid's theorem. Okay, so let's start. So we have this topic Euclid's theorem. Okay. So exactly what is Euclid's theorem exactly? To learn this, we will have to recall the basic division formula. Okay, so we know that this is dividend. Okay, and we know that this is divisor. Okay, and we know that after something we get remainder. Okay, and we also know that this is quotient. So if I ask you, what is the relation between these four key terms? So you have already known that there is a formula regarding these four key terms, which is as dividend equals to divisor into quotient plus remainder. Okay, so the formula is dividend equals to divisor into quotient plus remainder. Okay, so whatever term would be here, this would be dividend, and whatever term would be here, this would be quotient, and whatever term is here, this would be divisor, and the term here would be remainder. Okay, so there is a connection between these four key terms, and this is as dividend equals to divisor into quotient plus remainder. Okay, so let's move ahead. So to make some formula, I am going to say that dividend is A. I am going to represent dividend as A. Okay, and divisor as B, and quotient as Q, and remainder as R. So this formula will become A equals to BQ plus R. A equals to BQ plus R. Okay. So obviously this is remainder. So the remainder should be less than or equal to, less than divisor. Why? If it is equal to divisor, the divisor will divide it. Okay. So I'm going to write down the condition, and the condition is as remainder would be greater than or equal to 0, but would be less than this B, which is as divisor. Okay. So suppose if I'm going to divide 5 with 2, so you are writing 2 2s are 4, and this is 1. So we know that this is dividend. Obviously, this is A. We know that this is quotient, that is Q. We know that this is R and this is B. So there is a relation. What is the relation? 5 equals to divisor into quotient plus remainder. Okay. So this is A, this is B, this is Q, and this is R. So if I say you that the divisor is 2, so what should be the maximum remainder? Obviously, it is 1. Why? Because if it becomes 2, it will divide it. Okay. So the remainder is always greater than or equal to 0, because remainder cannot be negative. Okay. And it should be less than divisor. Okay, but I am going to say that remainder should be greater than or equal to 0 and less than b. Okay, so suppose if you want to learn, uh, suppose through this, if you want to solve, find the HCF of, find the HCF of 12 and 38. Okay, so see what we used to do. We used to divide it by 12. So 12 3 ja 36 and the remainder is as 2. Okay. So what you have to do? Exactly, you have to put the Euclid's theorem for this division. So you are going to identify that this is A, this is B, this is Q, and this is R. So can you write down the condition? Write down the relation. The answer is yes. So we will write A equals to BQ plus R. And we also know that if A equals to BQ plus R, so you will have to write the condition, that is 0 less than or equal to R less than B. Okay. So you will write 38 is equals to, what is divisor? This is 12. What is quotient? This is 3. And what is remainder? This is 2. Okay. So the first division has been narrated as 38 equals to 12 into 3 plus 2. Okay. And you will have to extend the division as this is remainder 2 and 12 is come here. Okay. And now you divide it. So 2 6 is 12 and this has been gone. Okay. It means 12 has become now dividend. It means this 12 has become dividend and this is divisor into quotient and this is remainder. So this divisor, this is the HCF we have studied. Okay. So HCF would be B. HCF would be B. It means HCF would be the value of B when we have got remainder 0. Okay. We have got remainder 0. Did you understand it? Well, so let's do one more problem. Okay. We have this question, find HCF of 765 65. Okay. So what will we do? Just see here. We will write down the formula, that is A equals to BQ plus R. And we will write 0 less than R less than B. Okay. This is Euclid's formula. You'll have to write in exam this formula first. Okay. So now see what will we do? We will put 65 here. We will put 765 here. And we will put 765 1 just 65. Okay. So after subtracting, we will get this. Now what will we do? We will again divide it by 1. So it will become 50. So what we have to do? 765 is A. Divided is 65. Quotient is 11. And remainder is 50. Okay. Now what happens? This 65 will come here. This is 1. This is 50. This is 15. Okay. So again, what we have to do? This 50 and 65. 65 has become dividend. So it will come here. This will become divisor. So 50 into 1 plus 15. Yes or no? Now what will we do? Again 50 will come here. So we will write 53 is a 45 and this is 5. So what will we do? 50 will come here and we will write 15 into 3 plus remainder which is 5. Now what will we do? This 15 will come here and we will write 5 3 is a 15 and this has been gone. Okay. So we will have to write 15 equals to 5 into 3 plus 0. Now see, this iteration process of Euclid's theorem, we have got the remainder 0. So at this stage, we have to stop and we have to see what is the value of B. So the value of B is 5. It means HCF is 5. It means HCF of 765 and 65 is 5. Yes or no? So did you understand it? Okay. So let's meet in next session. We will complete one more topic in next session. Okay. So thank you very much. Please like, share and subscribe my channel. All the best.